Hi everyone. Good evening guys. Very good evening all of you. How are you all? Everyone, how are you? Right, we'll be going for our discussions, right? All of you had your tea, coffee, snacks, chai biscuits, samosa, everything you had or nothing? Everyone. So we'll be going for these discussions, you can say, right? So what is that we'll be discussing now? So this next chapter of which one? This surveying we'll be discussing, right? Quick revision, right? Many topics gets over now. Is there many topics gets over? It will be continuing with which one? These other topics you can say, right? Right. So all of you, welcome to Unacademy. Let's crack it, right? Everybody ready to crack? Everyone get ready to crack, all of you, right? Nobody started commenting. Okay. So today will be the last date for this offer, right? Yeah, Messi Adar Sudhakar, good evening. So this today will be the last date for this offer, all of you. You can save up to this 55% off on this subscription amount. Yeah, Ayan Ransinga, good afternoon. So these new batches will be starting on this 31st January. Don't miss these batches. Up to 55% off on your subscription amount you will be getting. 12 plus 1, 15 plus 3, 24 plus 6 means up to 6 months extra subscription months you will be getting. Okay, right? Anandraj, good evening. So what is that referral code you have to use for availing all these offers, right? RP Civil is the referral code you have to use now. So now get together 28th January at 12 p.m. So what is that you can say? You stay tuned for the biggest launch, right? Whatever it is a launch you are having, right? So here this is Prarambh batch. This Prarambh batch will be starting on which one? Prarambh batch will be starting on this 31st January for 20-25 people, right? With which subject it was started, if you just observe? With this irrigation engineering it was started na? With irrigation engineering by Jaspal sir at 2 p.m. you can say. Now Vishwas batch for this 2026 it was started on January 18th with engineering mechanics by me, at which one? This 11 a.m. it was started every day, right? So what is that referral code you have to use always, right? That RP Civil is the referral code you have to use always now. These are all the books you will be getting if you are taking this iconic subscription, right? Ananya, good evening. So this no cost EMI option is also available for you, all of you. No cost EMI option also available, everyone, right? These are all GATE 2023 toppers. These are all ESE 2023 toppers, right? Now on 28th January, right? That is tomorrow only, no? At which time you can say at this 2:30 p.m. to this 5:30 p.m. you will be having this one. So can I take it at this 7 a.m. to this 9 a.m. this class, this one, everyone? That full length test I said na, surveying, shall I take it 7 a.m. because this is at 2:30 p.m. it is available, it is there na. So shall I take it in the morning 7 a.m. all of you? Deb, Subsandram. So this test on this which one? 2 hours I wanted to take it actually. 2 hours I wanted to take it actually. Shall I take it for 2 hours tomorrow? Shall I take it for 2 hours tomorrow? Morning 7 a.m. to 9 a.m. everyone. Is that okay? 7 a.m. okay? Because after that you'll be having the other classes and everything. Na? 7 a.m. I'll take, right? Is not? Okay. So use this referral code RP Civil and attend these, right, everyone, right? In the special class I'll be taking, right? I'll be sharing the link today, right? Today evening I'll share the link, right? कोई नहीं आएगा शुभ, right? अरे यार इतना एग्जाम का कितना दिन बाकी है, right देव? एग्जाम के लिए, right? और 4-5 दिन बाकी है ना? So 4-5 दिन के पहले so आपका मन थन ज्ञान बुद्धि everything you have to keep it on this examination only, no? ऐसा ना, you have to do it, right? Yes ना? Those who are willing to crack the examination, those who wanted to crack only will come, right? So बाकी लोग if they don't want they will not come, right? Don't worry. Why to worry about them? See, RP sir cannot make them to write the GATE examination, ना ऐसा ना. Right, okay. ठंडा बहुत है बट reduce हो गया है ना थोड़ा सा, right? अरे यार I have taken classes also ना, plus classes in this winter itself, right? 2 years back what I have taken? I have taken classes na, you forgot Dev, you also attended, and morning 6 o'clock itself I have taken the classes. You forgot those days, you forgot those days. In the February January itself I have taken these classes na, December. That surveying wala morning. Yeah, you should not think about all these things, right? Examination like Arjuna, na? Arjuna is seeing only which one is the eye of this bird. Like you have to see only the target examination, right? This chanda, garmi, right? Girlfriend, boyfriend, right? All these things chodna, right? Exam tak, right? All these will come and go, right? But your examination will come only once in a year, na? So you have to be careful, right? I used to call you. Yes, yes, I used to call all of you, those who are attending the class. Yes. Shall I call all of you now also? Okay, I will call you tomorrow then. So this is your, which one? This is GATE 2024. This based on the rank you are getting in this AMT, na, you will be getting this scholarship, you can say, right? Right. So these are all over, na. I'll be sharing the PDF after the class is over, okay? So which chapter? Chapter 6, traversing and omitted measurements gets over. Right here. Chapter 7, contouring over. Chapter 8, areas and volumes over. अभी अभी उतना टाइम नहीं है ना मैराथन के लिए because कब लेना है मैराथन राइट so morning 11 o'clock classes are starting and it will go up to night 10 o'clock classes are continuously present. When should I take? The time is not available, that is what actually. Two GATE plus courses are there, two GATE plus classes are there, one this free course is going on, free classes is going on, and one SSC JE plus class is going on. मैराथन के लिए टाइम नहीं है ना, इसीलिए मैंने ये कंसिडर किया था ना, ऐसा ना, ये शुरू किया था ना, ऐसा ना. सो क्विक रिवीजन पार्ट 1 पार्ट 2 पार्ट 3, नहीं तो एक ही सेशन में मैराथन करके कंप्लीट करने की कोशिश करूं मैंने, राइट? बट द टाइम इज दैट मच टाइम इज नॉट अवेलेबल ना, दैट्स व्हाई वी आर डूइंग दिस. ओके, दैट्स व्हाई वी आर डूइंग दिस एक्चुअली. Right, so here which one? This areas and chapter 8 areas and volumes gets over na, right? No. Chapter 9. So what is that we have to go for? This traversing gets over na, no, this traversing, contouring and everything gets over na, traversing, contouring and these areas gets over na, if you just observe. Now which topic we are left with if you just observe? Which topic if you are left with if you just observe? That tachyometry na. What is the tachyometry, you can say? That tachyometry is nothing but which one? Tachyometry is nothing but, right, when you can say it is a tachyometer if you just observe? When you are using this three crosshairs, you can call it as this tachyometer na, so no, only central crosshair if you are using, that is called as your which one? This theodolite. But if you are using the three crosshairs, right, when you are using this three crosshairs, top and bottom, right, what is it you can say, and central, right, all the three crosshairs when you are using na, it is called as your which one? This tachyometer, right? No, that is only tachyometer. The surveying done with this and analysis and everything done with this is called as your tachyometry, you can say, if you just have it. Is that clear? Is that clear? What is the tachyometer? It is the same theodolite only. When you are using this stadia hairs, then you can call it as which one? This is then you can call it as which one? This is tachyometer. That's it, right? There is no other change, right? Is there any change or there is no other change you are having, right? There is no other change, na? Right. So here if you just observe, right, what are the different cases you are having? There are distance d equal to which one? This is ks plus c, na? Yes, upper and lower stadia hairs we are using it. The distance d equal to that ks plus c, na? What is that you can say? Whenever you are observing this, right? So this is your staff, you can say. What are the readings you'll be getting? Upper stadia hair ray, it will go like this. This is your stadia reading, na? That is your staff intercept, na? Yes, that is your staff intercept, yes. And from this one to this one, what is the distance you can say? That is your d distance if you just have it. Yes, na? D equal to ks plus c. This is a main formula we are using or not? This is the main formula we are using, you can say, if you just have it. Now here what are the different cases? Different cases, right? First one you can say, right, what is it you can say? Horizontal line of sight, na? Whenever you are having this horizontal line of sight, right, what is it you can say? If you are having this horizontal line of sight, na? If you are having this horizontal line of sight, right, what is a horizontal line of sight, you can say? That horizontal line of sight if you just observe, na? So here this is what you are taking, right? What is it you can say? We are taking on to this benchmark, right? First and foremost reading will be taking it as this benchmark reading, that is your H, you can say. If you just observe that H you are measuring, and what is that you can say, this is your staff at this location, right? So here from this P to Q, right, what is the distance? D, you can say. This is a center line, you can say. This is your which one? This upper one, and this is your lower one. This is your what you can say, this is your S if you just observe. So what is the distance you are getting if you just observe? That distance D will be equal to that Ks plus C, you can say, right? That is your Ks plus C, right? Now what is this one? This is your central crosshair reading is R, na? Central crosshair reading is R, you can say, right? Now tell me, this is your P point and this is your Q point, right? How can you get the reducer level of this Q point? Tell me. Benchmark reducer level, right? What is it you can say? Benchmark reducer level plus what is it you can say? Plus H, right? This is your yes, you can make it, right? Not H. This is better, you make it as yes. Plus this back side, you make it, na? This is your back side, or this is yes, you can say, right? Oh, sorry. Already we are using yes for that, na? Okay. It is better we'll use H only. We'll take it as H only. Okay, don't worry. Or we'll use the term back side otherwise. We'll use the term back side, right? That back side is nothing but your H. So benchmark reducer level plus this back side, then you will be getting this one, na? So minus what is it you can say? Minus this or central crosshair reading, that will give this a reducer level of this point Q if you just observe, right? Is it clear? This is for this horizontal line of sight, right? Second one, what is it you can say? Inclined line of sight, right? What is it if you just observe? Inclined line of sight, right? Whenever it is an inclined line of sight, right, there are two conditions you are having. So that staff held vertical, right? What is it you can say? That staff is held vertical, right? Whenever that staff is held vertical, na? Staff is held vertical means, right? What is that staff? You can say that leveling staff at the target point, na? Whose details are required? The staff at this target point we have to consider or not? The staff at this target point, if you consider, that staff is held vertical, right? That staff is held which one? This is vertical, you can say. When this staff is held vertical, right? How it comes to be? This is your one, you can say, right? So this is the instrument location, right? Onto this benchmark, what is that you are taking? Onto this benchmark, the reading they are taking it as which one? This back side only, no? Absolutely. Now what is it you can say? This is your horizontal, no? This is your horizontal, you can say. Now what happens if you just observe? Three readings you'll be getting, na? So no, three readings you'll be getting, right? One bottom reading you'll be getting, one top reading, one bottom reading you'll be getting, one top reading you'll be getting, one central reading you'll be getting, na? So now these are the line of sights, you can say, right? So what is this if you just observe? This is your staff intercept, yes. And from here to here, right, what is it you can say? From here to here, that is your central crosshair reading, na? That is your central crosshair reading. And what is this if you just observe? From horizontal to the central crosshair reading, that is your V. And what is this one? This is your L if you just observe, right? And what is that angle made by this if you just observe with the horizontal? With the horizontal, the central crosshair is making an angle of which one? This is theta. So now what is it you can say? That L equal to that Ks cos theta plus C it will become. Because this distance is your which one? This D, na? This distance is your D, right? What is the D you can say now when you consider this triangle? D is nothing but your which one? This L cos theta. And what is that V you can say? V is nothing but your L sin theta, right? So L cos theta is nothing but what is it you can say? L cos theta is nothing but your which one? This L cos theta. What is it? L cos theta? Ks cos square theta plus which one? This is C cos theta. Okay, that is what. So that is what we are having, right? So what is it? V if you just observe? V is nothing but your which one? This is Ks cos theta sin theta plus what is it you can say? C sin theta, right? That is why you will be getting this V, right? But my suggestion is you remember this one and this one only, right? Don't substitute and remember, right? Don't remember the substituted format because it is very difficult to remember if you're remembering the substituted format. So then what is that RL of this Q point? You can say this is your Q point ground point, na? Then RL of this Q point is nothing but your benchmark reduce level, right? Benchmark reduce level plus this back side if you are making, na, we will be getting the reduce level of this horizontal plus V if you observe, na, then it will go to this central crosshair reading, na, plus V. Next, what is it you can say? Minus R if you make it, na? That will become the ground Q point, na? Like that you are having, right? Is it clear? Is it clear, everyone? Is it clear all of you how to go for this? Inclined line of sight, staff held vertical. Inclined line of sight when staff is held vertical, right, like that will be having. So trigonometry only, it is simply, right, it is not even surveying, you can say it is just a trigonometry only, right. That staff is held vertical. No? Now do you give guarantee that always this staff is held vertical? No, no. So now what is it, you can say staff is normal to which one? This line of sight. Staff is perpendicular to this line of sight. No? Staff is perpendicular to this line of sight, you can say. So this is your ground level. No? So this is your which one? This yeah, drawing the diagram is very very important, right? If you draw it properly, then you will get the answer clearly, right? If you draw the diagram properly, then you will get the answer immediately, right? Is not understanding the question and drawing the diagram according to that is very important, right? This is your backside, you can say, right? Now what is it, you can say this is a central crosshair. So this is a central crosshair line of sight, right? So whenever it is going like this, right, this is your lower crosshair, you can say that this is your which one, this upper crosshair projection of this. So now you will be keeping this staff vertical like this, right? You are keeping this staff in which manner? That is vertical like this, right? This is your Q point, this is your Q point, you can say, right? Got it? Now what is that? From this center, the reading you are getting, it will be which one? This R, right? Always, okay? Now from the central crosshair to the horizontal, right, always it will be how much? That is your V only, right? Always it will be taken as your V only, right? So this is your L, you consider. This is your which one? This L, if you just observe. So the central crosshair is making, central line is making how much angle with the horizontal? Right? That is a theta it is making, right? Now what is that, you consider? From here to here it will be the distance D, from this P to Q. This is your distance D. Now we want this horizontal distance, right? But what is that we are doing, if you just observe? That L equal to that Ks plus C only will come, right? Because this staff is perpendicular to this line of sight, perpendicular to this rays. So that is why L equal to Ks plus C directly you are getting, right? But what is that D equal to? That D is nothing but your L cos theta minus which one? This R sin theta will come. L cos theta minus which one? This R sin theta will come, right? And what is that V, if you just observe? V is nothing but your L sin theta. Like that you will be getting that horizontal L, and substitute this L here and get this D, get this V. Now what is the reducer level of this point Q, if you just observe? Benchmark reducer level plus backside. Then what it will go? Plus backside, what it will go? It will give the reducer level of this horizontal. Then if you go to this V, plus V, what it will go? Plus V will give which one? This reducer level of the center crosshair projection onto the staff, right? Then if you are going for this downward, we have to go for now. So what is it, you can say plus V minus what is that? R cos theta, right? Minus this we have to come down, and so no, that is R cos theta, you can say, right? Like that will be getting, if you just observe it. Is it clear? Like that will be getting, right? So this is also L cos theta plus which one? This R sin theta. Yes, L cos theta plus R sin theta. Yes, because it is exceeding the, like that you can say. Okay, note this and tell me. Clear everyone now? This one. So for this which one? For this angle of depression also you have to do in the same manner. For angle of depression also you have to do in the same manner, right? I'm not going for this angle of depression, right? Mostly that angle of elevation will come. Similarly you do that, right? Similarly you do that, you can say, right? Yes, now subdense bar method, or you can also characterize which one? Subdense bar method, or you can also characterize which one? This movable hair method. Stadia hair, fixed stadia hair method we have discussed till now. Till now, whatever those conditions comes, those are fixed stadia hair conditions, is that no? So now what is it, you can say, if you just observe, we'll be keeping this, right? Always this S comes into picture, so no, this is your center, you can say. This is your how much angle? That is your beta by 2, and this angle is also which one? This beta by 2, right? Always will be getting this subtense bar method, means movable hair method, right? We have to move the hairs such that, right, what will happen? You can say same staff reading will come into picture, right? This is your S by 2 staff reading, and this is your S by 2 staff reading. Then what is it, you can say that tan beta by 2 equal to Our final aim is to find out this distance d only. No, tan beta by 2 is nothing but your which one? This s by this 2d. Na? Tan beta by 2 is equal to which one? This s by this 2d, right? Then what is that? D equal to that s by beta, right? So that beta is in which one? If you are substituting that beta in this radians, we can use this formula, right? So what is that? You can go for s by which one? Sorry, s into 206265 into that s, sorry, 206265s divided by which one? You can say that divided by which one? This beta. So when beta is substituted in which one? This is seconds, then you have to use this formula, right? Got it now? Got it now? Clear everyone? This is your which one? This is a substance bar method, right? What is another method you are having? If you just observe, what is another method you are having? If you just observe of it, another method will be which one? This is a tangential method, na? Yes or no? That is your tangential method, you can say. So what is the tangential method? You can say here do we use this here do we use this or upper stadia here and lower stadia here we will use, or we will be using only the center line? Only center line used, no? So no, center line used, you can say, right? Center line is used, you can say, right? Like that, what is that you are having? So here first case under this, right? Angles of elevation, right? Both are angles of elevation only, right? Both angles of elevation only, yes, no? So this is your which one? This is staff reading is fixed, na? Here you have to be careful. This is your which one? This benchmark, you can say. On this benchmark, right? What is that you will be having? That is your back side you will be having. We will be getting on this benchmark, na? Back side you will be having, right? This is your benchmark, you can say. Now what is it, right? This is your horizontal, exactly, right? Isn't it? Now we have to keep the staff such that, right? Keep the staff such that these are fixed, na? This staff intercept is fixed or not? That staff intercept is fixed, you can say, right? This is your yes, if you just observe it, isn't it? Now how it will come? This bottom one, let us say it is making some angle of elevation, right? Top one it is making some angle of elevation, na? So top, let us say that is your alpha 1, bottom that is alpha 2 angle of elevation it is making, right? Isn't it? Now this is your Q point, if you just observe. What is it? You can say from this from this bottom itself you consider it as this R reading, right? Because center line is not there, na? Upper stadia, lower stadia, like that, those kind of things are not there, na? Now this you take it as which one? This V. Okay. Now what is this horizontal distance? This is your D, if you just observe. Okay. Now how can you get that? If you just observe that D will be equal to which one? Yes, by simply that tan alpha 1 minus this tan alpha 2, na? Tan alpha 1 minus this tan alpha 2, na? That V equal to which one? This D tan alpha 2. V equal to which one? This D tan alpha 2, you can write like that. Then what is that? Reduce level of this point Q, you can get it. So V we know, D we know, reduce level of this point Q equal to that first benchmark reduce level plus back side. If you are taking, then you will be getting the reduce level of this line of sight, horizontal. Then plus V, you will be getting the reduce level of this point, right? Minus R you have to make it, right? Isn't it? Like that, if you just observe. Got it? Suppose if both the angles of depression only, when both are angles of depression only, right? What is it you can say? Both are angles of depression only, right? How it is possible to go for that now? This instrument is at a higher elevation and this staff comes to be at the lower elevation. Instrument is at higher elevation and this staff comes to be at the lower elevation, you can say, right? Isn't it? So this is your staff, if you just observe, and it is your what? Benchmark, no? So that is your benchmark, staff at the benchmark, you can say, right? Now what is this one? This is your what is that you can say? This is your which one? This is your which one? This instrument, if you just observe, right? Now up to this back side, right? On the benchmark, whatever the reading you are taking, that is called as your back side, no? Now coming to this is a center line. Now what readings will be taking right here? Here if you just observe what readings will be taking, you can say. So this is your yes, no? So this is your yes, you can see if you just observe, right? So this is your R, no? This is your R. What is that you can say, right? This is your which one? This Which one is taken as V? If you just observe, which one is taken as V, right? This bottom to this, it is up to taken at it is V, na? That lower fixed staff reading to this horizontal, that is taken as V always, right? Now coming to this, right, first one, what is you can say, this higher angle bottom, there topmost is taken as alpha 1, here bottommost is taken as which one? This is alpha 1, right? This is your alpha 1 angle. To the top one, what is this angle you can say? That is your alpha 2 you can say, right? This distance will be taken as your which one? D. Okay. Now, what is that you can get it if you just observe that D will be equal to which one? Same S by this tan alpha 1 minus this tan alpha 2. Now, same thing only, right? There is no change. And what is that V? You can say that D tan alpha 2, right? This is also same expression, na? But only thing is reduce the level of this Q will change, right? This is your Q point, ground point you can say. What is that you can get? Benchmark reduce level plus backside. Benchmark reduce level plus this backside will go reduce level of this horizontal minus V. Backside minus V. There it was plus V, na? But here it is minus V minus R, right? That here in the angle of elevation, both are angles of elevation, plus V will come. If it is angle of both are angles of depression, minus V will come, right? That is the only change you have to observe here, right? Is it clear? Is it clear, everyone, all of you? Both are angles of elevation and both are angles of depression. And what is another possibility you can say? One is angle of elevation and other one is angle of depression possible, na? One is angle of elevation and other one is angle of depression possible or not? Yes, na? Note this and tell me, all of you. Right? Clear? Now I'll be moving on to this, right? One is angle of elevation and other one is angle of depression. And what is it you can say? This A, B, C condition. Right? What is it you can say? One angle of elevation and which one? One angle of depression. AE means angle of elevation, AD means angle of depression or not? Yes, no? Like that if it happens in this manner. This is your Q point you can say. This is your horizontal. Up to this we'll be having this which one? This angle of depression. Up to that we'll be having which one? This angle of elevation, right? Isn't it? That is your angle of elevation, right? What is that? If you just observe with respect to this horizontal, right? So this bottom is your alpha 2, right? What is that angle of elevation? Alpha 1 you can say, right? This is your staff intercept S now. That S value will be fixed here now. Always from the horizontal to this which one? Bottom it is V. And what is this one? This is your R always, right? This is your R always. Yes, now? Now you'll be taking on this benchmark. This is your benchmark you can say. First and foremost reading we have to take it on this benchmark only, no? What is the reading you are taking on the benchmark called as? This is called as your backside reading or not? Yes, this is called as your backside reading, right? From here to here, right? What is it you can say? From here to here it is called as your D, na? Now what is the D you can say? That S divided by which one? This is tan alpha 1 plus tan alpha 2 it will become, right? Plus tan alpha 2, right? What is the D? Sorry, what is the V? Same. D tan alpha 2. Now what is the reducer level of this point Q if you just observe? First we go for the benchmark reducer level. For the benchmark reducer level, if you are adding this back side, then what it will become? Reducer level of this horizontal, right? Minus V if you make it, minus V if you make it, right? What it will become? Reducer level of this bottommost fixed position on this staff, na? Now minus R if you are making it, right? You will be getting the ground point or not? You will be getting the ground point reading you can say. So this is about your tachyometer, right? Is it clear, everyone, now? This is your tachyometer. It is a clear, all of you. What is the tachyometer and everything? This is your which chapter? You can say that ninth chapter tachyometer we have mentioned, na? Yes or no? Now, so we'll go for this 10th chapter, right? What is it you can say? Horizontal and this vertical curves if you just observe, right? What is it you can say? Horizontal and which one? This vertical curves if you just observe, right? Horizontal and which curves we are having? Vertical curves if you just say. Now, whenever it is this horizontal curves, right, what is that we are having? Horizontal curve, right? What is the horizontal curve? You can start in this horizontal curve, right? First and foremost one is simple circular curve. Now, if you just observe, what is a simple circular curve or not? Simple circular curve, right? For this simple circular curve also, right? What are the parameters will be having? That a relation between this degree and this radius, right? What is that? Do you remember, everyone? That a radius will be equal to that 1719 by which one? This is a degree, you can say, right? Is na? Or 1719 by which? Oh, sorry, 1719 by this degree, na? When you can go for this, if you are using this 30-meter chain, na? This is for which one? This is 30 meter, right? This is for which one? This 30-meter arc or chain. 30-meter arc or this 30-meter chain, you can say. So that radius will be equal to which one? This 1146 by which one? This D. This is for which one? This is for this 20-meter arc or this 20-meter chain. Na? This is your 20-meter arc or this 20-meter chain, you can say, right? Like that, isn't it? Now, there are various formulae you will be having for this simple circular curve, right? What are the various formulae you are having, all of you? So, what are these various formulae you are having? If you just observe, originally it is like this, no? So, no, originally it is made like this, right? Now, what happens? These are the two straight lines, right? They are meeting, right? This is the delta deflection angle, you can say. Now, what is it we are doing? We are converting that into which one? This is circular curve, no? So this particular point is your T1, this particular point is your T2, you can say, if you just observe, isn't it? This is your intersection point I, or you can also represent it as V if you just observe, is not? Now coming to this, right, what is that you can say? So length of this curve, right, what is that you can say? If you are just joining this center, na? This is your radius you are getting, isn't it? This is your center of this circle, right? This is your which one? This is delta by 2, na? This is also which one? This is delta by 2. Welcome, right? What is this? This is your radius r. This is your radius r, right? Now from here to here, right? What is that you can say? Chord length capital L. So from here to here, right? What is that you can say? This is your curve length small l. So this is your C point. You can say this is your D point. You can say this point is, that point is your C. This point is your D. If you just right, is that clear? No. That is your mid-ordinate, na? So that is your mid-ordinate O naught or not, everyone? That is your mid-ordinate O naught, or you can also give it as the symbol M, you can say, right? Isn't it, everyone? The first and foremost one, what is it you can say? Length of this curve, right? What is it? Length of this curve, you can say that is your T1C T2, na? T1C T2 will be the length of this curve, you can say, right? How can you get this T1C T2 if you just observe? That is given as which one? 30 delta by this degree, right? 30 delta by which one? This is a degree, you can say, right? That degree, right? 30 delta by which one? This is 30 delta by which one? 30 delta by which one? This degrees, na? Son. Or, okay, 1 second, I'll just try to go for this in a easy formula. What is it you are having? R delta, na? Yes, no, R delta, right? R delta will be your length, right? Yes, no, R delta will be your length, you can say, right? Yes, no, R delta, simply you can go for it. If it is in the radians, na, like this, right? If it is in the degrees, what we need to do? So here delta is in which one? This is radians, you can say. So what is that? R delta into what is it you can say? That is your pi by 180. When we have to go further, right? If that delta is in which one? This is degrees, right? If the delta is in which one? This is degrees, you can say, right? Like that. Length of this curve you are getting, right? Now tangential length, right? What is the tangential length? You can say that a tangential length is nothing but your T1V, na? That a T1V equal to that T2V, right? Yes, T1V is equal to that T2V is nothing but your which one? This R tan delta by 2, na? R tan delta by 2, right? The delta is in degrees, right? Do you remember that? Now, third one, right? What is the third element you can say? Long chord. What is that? Long chord length, everyone? Long chord length capital L is nothing but your which one you can say? That is your T1D T2, na? T1D T2, if you just have it, it is T1D T2 is the long chord length, na? That L will be equal to how much? 2R sine delta by 2, right? What is it you can say? 2R sine delta by 2, right? That is your long chord, you can say, if you just observe, right? Next, what is that apex distance? Apex distance is nothing but your which one? This VC or this is CV, right? This is called as your apex distance now. So from here to here it is called as which distance you can say? This is your apex distance now. This is your apex distance you can say, right? I to C or this V to C. What is the apex distance that V to C? It is given if you just observe R into how much? Secant delta by 2 minus 1 R into that secant delta by 2 by minus 1, right? And now what is it? You can say mid ordinate. What is it? Mid ordinate, you can say if you just have mid ordinate, right? O naught is the symbol we are giving now, that is equal to that CD na. So C is the central point on the curve and D is the central point on the chord na. Curve to this chord, that is your mid ordinate, right? How can you get this O naught equal to R into what is it? You can say 1 minus cos delta by 2 na. Or you can also write it as this O naught equal to that R versine, right? R versine delta by 2 na. Listen, or 1 minus cos delta by 2, or you can also write as this versine, right? Is not versine delta by 2, right? Is that clear, everyone? So these are the different things we are having, right? Different properties of which one? This is circular curve, right? Formula for which one? This circular curve, simple circular curve. Second, right? Now setting out of this curve, shall we go for? This is your which point you consider? That is your third point, na? If you just go for this setting of this curve, so whenever it is that is setting of this curve, if you just observe, what is it? You can say first one, offsets from long chord. Whenever it is that offsets from this long chord, how can you get that offsets from this long chord? If you just observe, this is what you are having, so no, this is your O naught you are having, is not? That is your O naught you are having, you can say. And at this x distance from this center, na, what is that you are having, right? That is your OX you are having, na, O suffix x, right? Left side also symmetric, na, only one side if you calculate, other side also it will be same, na. This is your OX you can say, right? Like that, isn't it? That O naught already we know it, na. So no, what is that O naught already we know it, na? Just now we calculated this O naught. Then what is that OX? You can say OX is nothing but your under root R square minus this x square. R is the radius of the circular curve minus R minus this O naught, right? This is your which one? Exact formula, na? This is your exact formula, you can remember, right? O x will be equal to what is it? You can say O naught minus x square by which one? This 2R, right? This is which formula? This is approximate formula, na? This is your approximate formula for this, you can say, right? What is that O naught? You can get it, right? O naught is nothing but your R minus how much? Under root radius R square minus this long chord, right? What is it? Long chord, capital L is the long chord, na? Small l is the length of this curve, na? Minus R square minus which one? This L by 2 whole square, right? That is how you are getting, right? At every distance we know the ordinates, then we can set out this curve, or radius we can set out this curve easily, right? Like that, is na? Then perpendicular offsets from which one? This tangents, na? Perpendicular offsets from this tangents. What is that perpendicular offsets from this tangents? If you just observe, this is the first tangent point, right? So here at this x, this is a tangent we are having, right? Let us say this is your OX we are having, right? So this is your x distance we are having. At this x distance from this tangent, right? What is that you are having, right? This is your OX, right? Like that we can get these ordinates from this center, na? Listen, from this tangent, na? What are these values? If you just observe, OX will be equal to that R minus under root which one? This R square minus x square, right? This is the exact formula, na? And what is the OX approximately? You can say that is your x square by this 2R, right? This is the approximate formula or not? This is your approximate formula, right? Do you remember that, everyone? Do you remember all these things, all of you? Next. Those are perpendicular offsets from which one? This tangent. Means corresponding to the tangent, they will be 90 degrees, right? They will be 90 degrees to the tangent, right? Now radial offsets from the tangent. What is the meaning of this radial offsets from this tangent? If you just observe that OX will be equal to how much? You can say that is your under root r square plus this x square, na? This is minus r, that is your which formula? You can say this is your exact formula, or what is it? You can say ox will be equal to x square by this 2r, right? That is approximate formula, na? This is your approximate formula. But if you just observe what is the meaning of this, this is your circular curve, you can say this is the center of this circle, this is your tangent, you can say, right? At this x distance when you are considering, na, what is that? If you just observe, we will be measuring the offset in which direction it should be, that offset must be projecting towards the center, na? So is it perpendicular or it is not perpendicular, right? It is not 90 degrees, na? This is your ox, right? At this place also, if you just observe, this offset will be like this, right? Because it is projecting, na, right? This is your which one? This ox, you can say, right? Ox, right? At this x value. So those are perpendicular to the tangent, but here it is difficult to, these are not perpendicular to the tangent, na? Listen. What is it you can say? Offsets from long chords produced. What is the offsets from these long chords produced? O1 equal to that C1 square by this 2R, right? Next, what is that? O2 equal to, that is your C2 by this 2R into, what is that? You can say C1 plus this is C2. Now what is that? ON, you can say ON is nothing but your Cn by this 2R into, right? What is that? You can say Cn minus 1 plus which one? This is Cn, right? So what is that? Cn, you can say Cn is the last subchord. Last subchord, right? What is that last subchord? Here actually if you just observe, this is the one you are having, right? This is the one, and after that, right, if you are taking this center portion, right, what is it you can say? This is your C1, this is your C1. When you are taking again this central portion, right, what is it you can say? This is your C2, like that. So again if you are taking this, right, what is it you can say? This central portion, this is your C3, like that you will be having, na? So subchords we have to make it, right? We are making this subchords if you just observe. Is that clear, everyone? This is for the setting out of this curve, third one. Okay, these are all linear methods, no? Setting out of this curve, linear methods or not? These are linear methods, means chain is chain or tape is compulsory, we have to use it now. Chain or tape compulsorily we have to use it, right? Next, fourth one, setting out of this curve, right? What is it you can say? Angular, no? Angular, right? What is that angular methods you can say if you just observe? First one, one theodolite method. What is it? One theodolite method, that is small delta 1 is equal to which one? This 1718.9 into that is C by R. Okay, 1718.9 into that C by R. What is that? You can say this many minutes you will be getting, na? The deflection angle. This many minutes you will be getting or not? What is that? C, you can say C is nothing but your chord length. And what is that? Delta 1, you can say delta 1 is nothing but your tangential angle. Okay, so that capital delta 1 is equal to that small delta 1. So similarly delta 2 also will be getting like that, right? So what is the capital delta 2? You can say that capital delta 1 plus this is small delta 2, na? Similarly, what is the capital delta n is equal to that capital delta n minus 1 plus which one? This is small delta n minus 1, right? Like that will be having, right? Do you remember this? That is your single theodolite method, right? Next one is your which one? This is a two theodolite method. Third one is your which one? This is tachyometric method. Okay, tachyometric method, you can say if you just have it, is not like that will be going for this, right? Now fifth one, if you just observe, what is the fifth one? You can say length of transition curve, right? What is it? Length of transition curve, you can say. What is that length of this transition curve, you can say? What is that? G into that small v square divided by which one? This is small g into that radius of this curve, or width of this pavement into that small v square by this which one? This r into that g, right? R. you can say. So here then L, this is your H na, this is your H super elevation, you can write this is your H super elevation, right? Super elevation H. Then what is that length of this transition curve, you can say, that is your N into that H na. So what is that N, 1 in N is which one? This is the rate of change of this curve na, son. Rate of super elevation, right? Rate of super elevation, right? That is your length of this transition curve, right? First method, you can say. Second method, what is the L, length of this transition curve equal to how much, you can say, if you just observe. These are all you know in this method na, so no need to worry more here. So time rate, what is the time rate, you can say, that is your BV cube, right? B is nothing but your width na, BV cube divided by which one? This BV cube divided by which one? This XRG, right? BV cube divided by this XRG, this is for the payment. And what is that, you can say, that LTC will be equal to capital G into that small v cube by which one? This XGR, that is gauge na, this is capital G is gauge, here the WB is the width, you can say. Next, what is that, you can say, third one, radial acceleration, and what is that, small LTC, you can say, that is your V cube by this CR na, alpha R, right? What is that alpha? That alpha is nothing but your dA by this dt na, rate of change of this acceleration or not? So, no, rate of change of this acceleration, right? Generally, what is that alpha taken? 0.3 meter per this second square per second, okay? Like that we'll be having, you can say, isn't it, everyone? This is for this transition curve we are having, okay? Got it now? So now what is the shift of this curve? Shift of transition curve, what is the shift of this transition curve? That LTC square divided by which one? This is 24R na? That is 24R divided by this 24R, you can say, right? Is that clear now? Coming to this vertical curves, this horizontal and vertical curves, and after that we'll be going for which one? We'll be going for which one? We'll be going for which one? Photogrammetry, right? With that photogrammetry it will be over, you can say, right? Is na? Now what is this we are having, right? Vertical curves, right? What are the two types of this vertical curves we are having? What are the two curves you are having, if you just observe? Two types of this curves, right? What are the two types of this curves? Tell me, which two types of this curves are there? One is your summit curve, other one is your valley curve, son. That length of this vertical curve, right? What is that length of this vertical curve will be equal to, what is it, you can say, this is your which can summit curve, you can say, this is your valley curve, son. Gradients are only forming na, this is your G1 G2 gradients are forming summit curve, and here what is it, you can say, that is your G1 G2 gradients are only forming this valley curve also na. Two gradients will be forming, two gradients will be formed to make the valley curve definitely or summit curve definitely na. What is it, you can say, that is your G1 minus this G2 net deflection angle, if you remember, G1 minus this G2 divided by which one? This R. What is it R? What is it R, you can say? This is a rate of change per chain length, right? So rate of change per this chain length, right? So now what is the second formula, you can say, if you just have that length of this vertical curve, right? Whether it is a valley curve or summit curve, simply vertical curve, you can say, LVC is nothing but, okay? How can you get that, right? That is your G1 minus this G2. G1 minus G2 is nothing but your net deflection angle, yes or no? Into that V square divided by which one? This 100F. What is it, you can say, 100F? What is the 100F? Centrifugal ratio na, V square by this 2GF na, son, V square by this 2GF, right? Centrifugal ratio, right? Based on this centrifugal ratio, F is the friction, lateral friction, and V square is the centrifugal force. V square is the velocity na, like that you are having. Is that clear, everyone? Everyone clear, all of you? Everyone is clear? Okay, right now photogrammetry, right? So this is which chapter? Photogrammetry. This is chapter 10, chapter 11 you can say. So what is that photogrammetry you can say? What is that photogrammetry if you just observe? That first relation if you just observe, what is the main relation you can say? Focal length f equal to that uv by this u plus v na. So that means, do you remember that 1 by f will be equal to that 1 by u plus this 1 by v na? The diaphragm distance and object distance, right? Both will be there na. So this you will be learning from this is 9th class or 8th class onwards. So this equation will be learning, is na? Everywhere it will come. So here if you just update, what is it you can say here? What is it you can say if you just observe? How can you get that? There are coordinates of this point you are having, na? So there are coordinates of this point you are having. Whenever you are having the coordinates of this point, coordinates of this one with respect to it, okay, otherwise we'll go for this. Let us say that scale, right? What is that scale you can say, everyone? Do you remember that scale? Scale will be equal to that, s will be equal to which one? This f by this capital H minus this small h, no? Capital H minus this small h or not? Capital H minus this small h, right? What is your capital H? Do you remember, everyone? What is your capital H and small h? This is your normal ground you can say. This is your which one? This mean sea level, na? So no, this is your mean sea level you can say. This is your flying height, right? Aeroplane with camera is flying at this place. So this is your which one? This is small h you can say, right? That is reduced level of which one? This ground point. And what is this you can say if you just observe? These are the 2 points A and B you can say, right? On this, these are small b, reverse it will come, okay, here it will come like this, na? This is your small a, this is your small b if you just wrote. What is this height if you say? That is your capital H minus this small h, na? This total is your flying height will be your capital H or not? This is your mean sea level, right? Mean sea level to this flying height, it is called as your capital H. See, if you just observe, majority questions they have given based on this only, right? Majority questions they have given based on this only if you just observe it, okay? Majority questions they have given based on this only, right? Just based on this scale only, majority questions they have given till now in this GATE examination also, okay? Right? Now, what is that average scale, right? Suppose, do you give guarantee that this h will be same everywhere? Suppose if the h is different at different locations, right? What is it you can say? From this mean sea level, right? This is your h1 you are having, right? This is your h2 we are having, right? Like that, if you are having like this, h3 so on like this, no? Then what is it you can say? H average will be equal to which one? H1 plus h2 plus this so on divided by this here, no? Divided by this here, right? Now what is this? It comes to be average scale if you just have it. What is the average scale? That S average equal to, what is the average scale you can say? S average will be, average scale will be equal to which one? That same f divided by this capital H, right? Minus this h average we have to go for, now minus this h average we have to go for, right? Now what is the next scale if you just observe? What is the next scale if you just observe? Datum scale. What is the datum scale? SD you can say. That SD is nothing but your which one? F divided by this capital H, na? Every point is projected onto the datum or this mean sea level, na? Yes or no? That is datum scale, right? Now what is that average scale? It is already done, right? Datum scale, right? Done, okay, you can say, right? Like that, isn't it? Here if you are having the coordinates of this, right? Small xa, small ya are coordinates on which one? Coordinates on this photo, na? These are the coordinates on this photo or not? Whatever the photo we are taking, right? That capital XA and this capital AY are which one? Coordinates on which one? Coordinates on this ground, right? If you just observe what is the capital XA, you can say capital XA is nothing but your H minus this is small HA, right? HA is nothing but reduced level of this point A. Divided by which one? F into that small XA, right? Similarly, what is the capital YA? Capital H minus this small HA divided by which one? This F into small ya. Okay, like that. Similarly, what is the capital XB? 2 points. Capital H minus this small hb divided by which one? F into the coordinate of this B point. Capital YB. Capital H minus this small hb by this F into that small yb, you can say. Isn't it? So like that, what is it? Length on this ground, if you just observe. Length of this 2 points, right? AB distance, right? Distance between the 2 points A and B, right? What is it you can say? Under root same, na? That is your XA minus this XB whole square. Plus what is it you can say? Plus this capital YA minus this capital YB whole square, na? Isn't it? Isn't it, everyone? All of you? Right? Next. Write the expression for this relief displacement, it will be over. This is your 6th one, na? Now what is that you can say relief displacement, if you just observe. What is the relief displacement? Relief displacement, right? What is it you can say? That relief displacement, that a small r equal to that a capital R F divided by which one? This capital H minus this small h, you can say. What is your capital R? If you just observe, capital R is nothing but your K naught into that A naught, right? That is your ground distance. From which point you can say? That is your ground distance from which one? Ground distance from the principal, right? From principal. Okay. So then, and also we know that R naught is a radial distance, right? This is your F naught, F divided by which one? F. Okay. Simply you remember that small r equal to that d equal to r into that capital H minus this small h by F into what is it you can say? That is your F h by which one? This capital H into that capital H minus this small h you are writing, right? So this d will be equal to which one? This r h by this capital H, right? This equation you remember finally, right? This equation you remember finally, right? Or you can also remember this as which one? This r naught into that r naught into that small h, right? Small h divided by which one? This capital H minus this small h, right? Either you can remember this one or that one. Both are same. If you are using r naught, na, capital H minus small h. If you are using this r, na, r h by this capital H will come, right? Like that. So what is that r naught? R radial distance from this point, na? So no. H, what is that h? You can say h is nothing but your height of this tower, na? Height of this tower, right? What is that you can say? Do you remember the relief displacement? Generally, if you are observing this from the top of this tower and bottom of tower should be located at the same place. But if you are observing from some inclined position, na, so top of this tower and bottom of tower are having some displacement. That is only relief displacement, na? That is only the relief displacement you can say. If you just observe. Is it clear? Clear, everyone? Shall we move to the next? Last one, last point. Right. Right. So what is that if you just observe? What is it if you just observe? Next, number of photographs, right? What is it you can say? If at all photographs, if you just observe, whenever you are going for this photographs, right, there will be overlapping conditions, that there may not be overlapping conditions, na? Without overlap, right? Whenever it is without overlap, right, what is it you can say? Without overlap conditions, right? What is the total number of these photographs required? The number of photos required, that is capital N will be equal to the capital A ground area divided by this which one? Ground area covered by this single photo, right? Total ground area, capital A is which one? Capital A is which one? This is a total ground area. Okay, capital A is which one? This is a total ground area. What is that small a? Total ground area covered by which one? One photo. It is full of a field. That is of a field. It is covered by which one? This one photo. One photo is covering how much area you can see, right? Got it. That is what. So here small a, how can you get that if you just observe? Length of one photo into this ground length covered by this one photo into this width covered by this one photo, na? So how can you get that? Length of this is photo divided by this scale into that width of this photo divided by this scale, right? What is it you can say? LW by this S square. Na? So these are your which dimensions? You can say photo dimensions or not? These are your photo dimensions. One photo dimensions. Right? This is which one? These are your ground dimensions of one photo area. Na? Ground dimensions of which one? This one photo covering area. Like that. Now whenever this overlap is there, with the overlapping condition is there, what is there you can say? Same, that n is nothing but your capital A by this small a only, right? That small a will be different, you can say. What is that small a? You can say that L into the W, right? How can you go for 1 minus this PL, right? What is the PL? What is the PL? You can say. What is the PL, everyone? This is your overlap in the length, percentage overlap in the length direction or proportion. Into what is the, you can say, W by this, yes, it will come, right? Similarly, into what is the, you can say, into what is the, you can say, just separate 1 minus, sorry, into L, sorry, L by S, right? Small L by S, into what is the, you can say, 1 minus this PW, na? 1 minus PW into that small W by this S, is na? Got it? PL is your length overlap, PW is your width overlap, if you just have read. Is it clear, everyone, now? Like that will be getting, okay? Is it clear? So this completes your which one? This completes your which one? This aerial photogrammetry. What is it? You can say time interval between exposures, right? What is that? Time between exposures, no? Time interval between these exposures, if you just observe, right? What is it? You can say that T will be equal to 3600 L by this V seconds, right? What is that? Yeah, good evening, sir. Good evening, KP sir. Time interval between the exposures, right? Do you remember that exposures, right? It is a time gap between which one? This two photo areas covered, na? Successive photo areas covered or not? It is the distance covered by this two successive photo areas at the ground, right? And what is the capital L? How can you get that? 1 minus this PL, right? How are you, sir? 1 minus this PL into which one? This L by this S, right? Means, can we say, just now we have calculated this capital N, na? What is it? It is the length covered, ground length covered, ground dimensions of this one photo covering area. So it is a ground length covered by this one photo, na? It's a ground length covered by this one photo when you are moving in the forward direction, you can say, right, like that, isn't it? Okay. What is the V? You can say, if you just observe, ground speed of this aeroplane. Excellent as always, sir. Okay. What is it? You can say, yes, sir, I am good, as usual. Ground speed, right? Ground speed in which units we have to take it? That you have to take it in this kilometers per hour, right? Like this completes which one? Aerial photogrammetry. Quick revision of this surveying is over, right? All chapters are over. Yes, now? Now, tomorrow, 7 a.m. to 9 a.m. I'll be fixing the time. 7 a.m. to 9 a.m. I'll be fixing the time. You will be having this live test on this, okay? Entire surveying you'll be having this live test. Shall I keep the time? Morning 7 to 9 a.m. All of you tomorrow. Because afternoon you are having this AMT and other classes will be there. Morning 7 to 9. Shall I keep it? Right. Somebody respond. Yeah, in special class, I'll share the link by tonight. And in special class only that will happen. They don't wake up. They said they will wake up, sir. Yeah, they said they will wake up. Right. I'll take the attendance and check how many of they are waking up or how many of they are not waking up. Otherwise, I'll call and wake. Okay, thank you. Any doubts you are having? Anyone, all of you? Anyone having any doubts? KP sir, know you very well. Very good. Right. Okay, I'll be closing the session. Thank you, all of you. Bye bye. Tata, everyone. Bye, sir. Thank you. So today this PDF also I'll be sharing in the groups. Okay, I'll be just adding them and I'll be sharing it. Okay, don't worry.